So, hello and welcome to all of you. So, here I, Arjun Gulia, am with Dr. Mila Mitra for another engagement session as the part of National Astronomy Challenge. Yeah, I hope you guys are doing well. And as we told you in the previous session, that is yesterday, that today we are going to talk about the citizen science project, right? So, the citizen science project that we are going to talk about is the Galactic Cruise. So, uh, I hope you guys are excited about it. Yeah. All right. So let's just begin and start learning about that project. But students, before I start telling you about that project, I would start off by telling you a bit about the galaxies and basically how do they form and what are the different types of that. And once I've told you that, it will be easier for you to understand the second part, that is the citizen science project itself. Yeah. So let's begin this. And if you have any questions, please feel free to ask your questions in the chat here. All right. So yeah. And I would also request you that once we are done with the session, and if you have any questions regarding the NEC, please stay back. I'll be answering your questions once this session finishes. Yeah. So let's just get started here. To start, uh, just give me a minute. So here, basically, this is our citizen science project that we are going to talk about. So let me just begin and start telling you a bit about the galaxy, right? So when we talk about the galaxy, the first galaxy that we all know about is our own galaxy, right? Our own world, like where the galaxy in which our own world is situated. Yesterday, when the sir was talking about, he was saying that he was saying a bit of stuff about the stars in the night sky. So let me tell you a very interesting fact. You know, no matter how many incountable stars that we have in the night sky, you would be amazed to know that most of the stars that we see and most of the rather things that we see in the night sky, they are actually what reside within our galaxy, right? And so much so that basically the Milky Way galaxy itself is an experience to have, right? Seeing the Milky Way galaxy itself is an experience to have. So if I were to show you the Milky Way galaxy, it is present right here in this picture. Now, those of you who know how the galaxy looks like, you can very easily identify where it is. But for those of you who don't know where the Milky Way galaxy is in this photograph, you may see that here in this photograph, obviously it is the photograph of a night sky and there are so many stars in it. But out of those so many stars, you will be able to find out that there is a band of stars which is comparatively very bright as compared to the others. This band. Now, this particular band is actually the Milky Way galaxy. Yes, so the galaxy, the Milky Way galaxy that we see, it does not look like a disk which you might have seen in different photographs. Right? Not the Milky Way. Reason being that, as you all know, we are inside the Milky Way. And since we all are inside the Milky Way, obviously we won't be seeing that disk, some far away disk, right? We will be seeing as if we are inside that disk. So just imagine if you are basically, if my hand is a Milky Way galaxy, if I'm right here somewhere in the hand, I won't be seeing the entire disk, right? So what I will be seeing is I will be seeing the edges of it if I were to see it from this angle. So that's what we see. This over here, this is the Milky Way galaxy, and it extends from one side of the sky all the way to the other side. So basically, it usually go like this, all the somewhere from southeast, southwest of exactly in the southern direction. It will go right over there and into north, and it will go like that. Yeah. So at one time you will be able to see the half of it. So that's what our Milky Way galaxy is. Yeah. Now moving forward, this is the Milky Way galaxy, and if I were to tell you, we as a part of a Milky Way galaxy, we are not at the center of it. Obviously, we are right here. If you can see, not too, basically not too close to the center of the galaxy, but not entirely at the outskirts. We are somewhere in the middle. Yeah. When I say we, I mean our sun. So you all must know that in our Milky Way galaxy itself, there are more than 100 billion stars. And most of the stars that you see in the night sky, they're the part of this Milky Way only. Yeah. And here is the thing, in the Milky Way, the next thing that you see is actually a very beautiful and a very massive core. So here, can you see this one, the center? This bright portion, it is called the Galactic Center. Right now, this Galactic Center, basically it is the force with which the galaxies are held together. Right? Like if I were to give you the example of a solar system, in the solar system, all the planets, they are held together by the gravity of the sun, right? So in the galaxy also, it is a kind of a disk only. But in the disk, it is not the planet, it is actually the stars which are held together by something very strong, right? So that something very strong is a black hole. And not a very normal or a small black hole. It is actually a black hole which is quite big, right? And that's why we call them the supermassive black holes. Now, these supermassive black holes have gravity so much that it can actually bind those 100 billion stars in its orbit so that it actually keeps on revolving around that center, right? And if those stars gets too close, it gets submerged or it gets swallowed by that supermassive black hole, right? So the supermassive black hole inside our Milky Way galaxy is called Sagittarius A. That is the name that we have given to that, right? And this is the black hole with which our galaxy is stable. Yeah. Now, let's talk about the universe. Here, I was just telling about our galaxy and how big, how vast our galaxy. But that is not the end of the universe. That is actually for us, that is the beginning. Right now, because in the universe, as we were telling you, there are more stars in the universe than there are sand grains on Earth, right? And why is that possible? This is because in the universe, there is not one, but more than a billion galaxies that we have projected to be present, right? So there are more than 100 billion galaxies in the universe. Out of those 100 billion galaxies, they all can have unique shapes, size, colors, and the different amount of stars also in them. Yeah. So this Galaxy Cruise project, it actually helps you to find more galaxies here. Yeah. So here, I'm showing you a video, right? This video actually tells us something about the galaxies and how they are formed. Yeah. So let's just watch this video and I'll elaborate on it further after that.
To get a better understanding of this topic, we need to know how galaxies are formed. As clouds of dust and stars swirl around space, gravity pulls other objects closer to it, eventually knitting them together to form one giant spinning pack of stars and dust. Slowly they get bigger and bigger by pulling other masses into it due to its ever-growing gravitational force. Collisions within the galaxy can then sling material towards the outskirts of the galaxy, thus creating spiral arms filled with colonies of stars. There are three main types of galaxies: spirals, ellipticals, and irregular.
Yes. So that's this is how the galaxy forms. Basically, what happens is that all the galaxies are star forming regions, right? Now, in these regions, the new stars keep on forming. And the older stars, they keep on getting closer to the galactic center as they are revolving around. Yeah. Now, since there are 100 billion galaxies in the universe, many times what happens is that two galaxies come very close to each other and then they interact. Or how do they interact? They just smash into each other. And when they smash into each other, the result can be anything. They both can combine to form a big galaxy, right? So obviously, some of the stars will shoot away from the influence of both these galaxies, and they will be basically left without any galaxy, like a cold, all by itself in the universe, right? So that will be the fate of some stars, but most of them, they get captured into these galaxies and form different shapes. So when we come to classify the galaxy, we classify them according to what kind of shape it has. And with this, we try to understand that what might have happened during the formation of this galaxy, right? How old it is, how it was formed, and all these kind of things. So let me just quickly tell you what are these types of galaxies. Yeah. So the first type of galaxy I'm going to tell you about is this one. So before I get to that, one more thing, like these galaxies, the name and their classification was first done by astronomer Edwin Hubble. Now it is the same Edwin Hubble after whose name the Hubble Space Telescope was named. Yeah. And obviously, it was a very worthy name if you ask me. Yeah. So if I were to tell you the types of the galaxy, so these are the basically the different types of galaxies here: spiral, barred spiral, lenticular, elliptical, and irregular. Right. So let me just get to that. First one, if I were to tell you about, is the spiral galaxy. Now, what is a spiral galaxy? Basically, it is a galaxy which have a spiral, which you can see like it has an entire spiral on it. If I were to make it, you can easily see this, right? It has a center and it have a very prominent arms over here, which are going to the center in the form of spiral. Yeah. And thus the name spiral galaxy, right? So here is the thing. Now, most of the young galaxies, no, they are the spiral galaxies only. Why? Because when these stars they start orbiting a supermassive black hole, the young stars they actually get more stable in the kind of a disk, what we say, orientation. Right? It is the same reason why the in our solar system also the planets are all in a disk shape. Why this happened, that is a different topic altogether. But yes, this is how the spiral galaxy looks like. Right. So spiral arms, so it has basically the long arms which are spiral, and which is the parts where most of the stars reside, and this is the part where the new stars keep on forming. Then there is a central bulge. That central bulge is the bright region at the center where you will see like the supermassive black holes and all the older stars are there, right? And there are lots of dust and gases are present in it. So you will find that whenever you see these galaxies, they look kind of fuzzy. Yeah. So our sun is located in the arm of the barred spiral galaxy. Yeah. So this is the spiral galaxy. Now, when we see these spiral galaxies in the universe, different spiral galaxies in the universe, we find that even though spiral galaxies look, the arms are forming a spiral, but the spiral that they forms, it is not consistent. Right? Not every galaxy has the same type of spiral. Sometimes the spiral is such that they are very close to each other, like the entirely closed kind of structure. If that happens, the galaxy becomes this type of galaxy, right? A very close spiral. Or sometimes what happens is that the spiral arms are there, but they are a bit open at the ends, as you can see here. Yeah. Or it can be like if you feel that you will find that there are some kind of galaxies which have arms which are curving, but instead of curving, it is kind of a very open spiral where it forms sometimes form like a letter S, right? So basically, how open their spiral is, based on that we classify them as SA, SB, or SC. A means the closest, B means slightly open, and C means completely open spiral. Yeah. Similarly, second one out of the spiral galaxy is the barred spiral. So what is a barred spiral? It is just like the spiral galaxy. Only difference is that in the spiral, the core is circular. In barred spiral, it is kind of a chocolate bar and not a circular core, right? So that is the only difference, right? It has a complete bar at the center, and all the spiral arms which are there, they actually originate or they actually start at the end of this bar, as you can see here, the arm, the bar, and the other arm. Right. So as you can see, like these galaxies also can have different type of spiral. It can be very close. It can be quite open. Right. And they also have the formed of the new stars and have many different star forming regions, which are in the arms. So over here, just like the spiral, it is just like that. Closed spiral, SBA. Here S means spiral, B means barred with a bar, and A, closed spiral. B, slightly open, C, completely open spiral. Yeah, so this is the barred spiral. Now, if I were to talk about our Milky Way, now our Milky Way is also a barred spiral. It is a kind of a type SBA type of galaxy. Yeah. And then comes the elliptical. Now, elliptical are the type of galaxies which are actually very old. Now, these are usually the galaxies which formed at the starting of the universe when the first galaxies were forming. Right? Those galaxies are usually elliptical. Why are they elliptic? So basically what happens now in the spiral galaxies, if I were to tell you about the spiral galaxies first, what happens is that as the star, they keep on revolving around the galactic center, in the spiral form, they're actually keep on getting closer and closer to the galactic center, right? And as they kept on getting closer and closer, what happens is that by the time they reach at the later stages of their life, they're very close to that what we say the central bulge, right? And most of them are eaten into that supermassive black hole. So what happens in the older galaxies that new stars keep on forming, old stars either they keep on dying or they kept on getting very close to that center of the a supermassive black hole of that galaxy. So you would see that slowly the spiral arm starts getting disappearing, and all the stars start getting crowded towards that supermassive black hole. So basically, the shape of that spiral actually shifts from spiral into a big kind of ball with billions of stars in it, right? And that, when it happens, will become an elliptical galaxy. So it will shape like a sphere, looks like an ellipse when you look at it from the distance, and it will mostly have old stars and no new star forming, right? And this is how it will look like. So if you were to see it, you will mostly see it as a halo or a diffused star kind of structure, right? But if you look at closely, you will find that it is not one star, but a billions of stars clustered together, forming the elliptic. So again, just like the spiral, not all elliptical galaxies, they are circular. Sometimes they're circular, sometimes they're elongated, sometimes they're very elongated. Depends how much the stars have crowded towards the supermassive black hole. Right? So one which is a complete circle, it will become E0. A bit elongated E1, E2, E3, E4, and the E7 will get so elongated that it will easily resemble like a spiral galaxy. But you will find that there is practically no distinguish between the central bulge and the spiral arm. So we can say that very easily that it is an elliptic. Yeah. So this is the different type of galaxies. The elliptical, which go from E0 to E7, spirals, SA to SC, barred spiral, SBA to SBC. Yeah. And then comes the irregular. Now, irregular is a type of a galaxy which actually does not have any shape. Like you remember the video I showed in which the galaxies were interacting? When these galaxies were interacting, not every time they will form a prominent or proper structure, right? Which is a proper spiral or proper diffused hollow sphere, right? Sometimes what will happen is that it gets any other shape which we cannot classify. So all these other shapes which we cannot classify, we keep them into one particular group. We call them all irregular, right? They don't have any symmetry, any structure, or basically it can have one part can be very dense, one part can be very shallow. There is no complete structure in it. That's why we call them the irregular, right? And with this, these are all about the types of galaxies here. Now, to tell you more about this project, so the reason I was telling you about this is that I wanted to tell you about the galaxies before we dive into the project. Reason being that in this project, we are going to learn how to find the galaxies only. And now since we have learned how to find the galaxies, so now I would like to I'd like to invite Dr. Miller. So hello and welcome to Dr. Miller. And I would like to ask her to take it further and explain them how these galaxies interact and what does it has to do with the citizen science project that you want to tell them about.
Hello, everyone. And that was great. I can see some of you really enjoyed looking at these galaxies and talking about it, which, Arjun sir told you so much about them. So I'm going to tell you more now about galaxy interaction. And then I'll tell you, about the citizen science project, and I'll show you exactly how to do it. So let's move ahead. Arjun, you can see my presentation?
Yes, ma'am.
Okay. So I'm going to tell you a little bit more about interacting galaxies. Arjun sir just told you about galaxies, but did you know that they interact with each other? What does that mean? It means that if there are two galaxies, two or more galaxies close to each other, then you'll see that they actually interact, their masses interact. So galaxies are rarely found in isolation. They're usually found in groups or clusters. Okay, so interactions are of two or three types. The most common one is called flyby. And you yourself know the word flyby. It means it's just going fast. So galaxies interact because of their gravitational fields. The gravitational fields of one influences the other one. It might pull it a lot or a little bit. So this kind of interaction, which is flyby, is the approach is just close enough that the gravitational fields influence the other. So that what can happen? The shapes can change, new structures may form. Okay, so you have a picture here of the Whirlpool galaxy, and that one you can see shows some signs of interaction. Another type of interaction is merger. So merger is a stronger interaction, and for merger, it's galaxies of approximately equal masses. So flyby was, when there's a lesser influence. For merger, there's a stronger influence, and you can see that the example here is a galaxy called antenna, because it's got two structures on top that look like antennae. So this is a merger where there's a lot more change in shape, and they have interacted very strongly so that they almost look like one galaxy now. Okay, so what do interactions do? They change the shape and create new structures. So there are some kind of shapes that you can recognize, and from the shape you can tell that there's an interaction going on. So the first type is called warp. Warp means a bend. Okay, so this is a warp. Then sometimes there are tails. This looks like a tadpole, right? So tadpole with a long tail. So these are called tidal tails, where there's a tail well beyond the main part of the galaxy structure. Okay, so this is an example of a tidal tail. Sometimes you see shells or rings. So here, the elliptical galaxy is in the center, and you see shells or rings around it. So this is another kind of structure you see. So an interesting part of what happens during interactions is what is called, Arjun sir said that some parts of the galaxy show star formation. But when there are interactions, those create new bursts of star formation. So in such interacting galaxies, you can see a lot more star formation happening. Like the image on the right-hand side, those white and bluish dots are all star formation regions. Okay, so sometimes there are multiple interactions. So here's an example of M81. This is the Messier. M means Messier. So Messier catalog, Messier is a catalog of deep sky objects that was found by an astronomer called Charles Messier. So this particular image shows multiple interactions. Now, sometimes different wavelengths reveal different things to you. So on the left-hand side, it's the same galaxy in optical or visible wavelengths. I mean, there you can only see the two galaxies. You don't see the interaction. But on the right-hand side, it's a radio image. And in the radio image, you're actually able to see how they're interacting. You see the wispy structure merging the two, and you see long tidal tails which connect the galaxy. So this is a good example of merger. And I also wanted to show you that sometimes you can see more in different wavelengths that you cannot see in visible. Okay, here's another example. This is the Cartwheel galaxy. Earlier, and why Cartwheel? Because it is like a wheel. You can see a central structure, and you can see a rim, and that rim has spokes. Spokes means like a bicycle. It has the lines that lead up to it. Okay, so originally this was like the Milky Way Galaxy, and it was similar to our Milky Way. And then a small galaxy plowed through its center. It went through the center. As a result, this interaction created a bubble kind of structure that looks like a wheel, and that's much further out than the main part of the galaxy. And there are also the spokes of stars and gas. And all around the rim, you can see star formation in the white and blue, very bright areas. So, I talk so much about galaxy interaction. Are they common? Why am I talking about it? We're going to go through a citizen science project, but are we going to find many interactions? Okay, so interactions are common in the local universe and also in the past. 6 regions from the Hubble Ultra, right now here, I have 6 regions from the Hubble Ultra Deep Field camera, and you can see a lot of merging and interacting galaxies. And furthermore, any individual galaxy may have gone through several interactions. So the the structure keeps changing. So galaxy interactions are very important to study because they're important in the development of galaxies. Okay, so today I'm going to talk about a citizen science project called Galaxy Cruise. And today you have a special treat. Once I'm done talking about this project, we are going to introduce you to a young astronomer who's a class 10th student who's participated in a lot of such projects, and he's made his name in astronomy even at the school level. So in a little while, I'll introduce you to him and we can all interact with him. So today, we are going to talk about this citizen science project called Galaxy Cruise. So all of you who have your laptops, you can copy this and maybe open this page with me. Otherwise, you can try it out later. I'm going to walk you through most of the steps, okay? Okay, so yeah, Galaxy Cruise, let's take a look. So what is this project about? It's by the National Astronomical Observatory of Japan. That's NAOJ. Just the way you have NASA and ISRO, there's also NAOJ. It's from a large-scale survey program using a telescope called the Subaru telescope, and the camera is called the HSC, Hyper Supreme Cam. So what is the aim of the project? Again, to explore the universe with Subaru and look at interacting galaxies and classify them. And this is a project this is what citizen science projects do. Public and scientists come together to solve the mysteries of the galaxies. So whatever you as a citizen scientist contributes as a result, astronomers will actually analyze your results and gather your results and come up with scientific answers. Okay, so again, this is the Galaxy Cruise, and you will have the YouTube link, but this is you can look for it, you'll find it. You have to first register yourself. All you need to register yourself is an email ID. Then you have to finish a training, which is in 3 parts, and then you can start participating. And right now is a great time to participate because from December 11th, there is a 1-month campaign ongoing where if you identify or classify 1,000 galaxies, you will get a special certificate. Okay, so with that, I'm going to take you straight to the website. Okay, so Arjun, I hope you can see my website. Yeah.
Oh, yes, ma'am.
Okay. So this is the website for Galaxy Cruise. So first thing you have to do is log in. And if you don't have a login, you can make your own login. You can get started. If you slide down, you can see get started, become a citizen astronomer. So all you do is click on this and you can make an account. All you need is an email ID. Okay, so that's very easy. So now I'm going to log in because I already have a login. So what happens when you log in? So there's a whole movie about what is Galaxy Cruise, and you can watch that. So I'm going to, since I told you a bit about it, I'm going to rather go ahead and show you how to get started. Okay, so what you do to get started is first do the training. So once you get in, first you click on training. Okay, so now I'm going to walk you through this very quickly. You can take your time and do it peacefully at your homes. So the first lesson is the introductory, and it's a practice of, is the galaxy they're showing you, is it elliptical or spiral? Like Arjun sir showed you, elliptical galaxies are the ones on the left. They're like an egg shape. So they have a 3D. They're an oval that's oval from any side, whereas spirals are like a disc shape. So they're flat, as well as they have spiral arms. So those are the features you are looking for. Okay, so now you can practice. Let's do a couple of them to practice with me. So the first one is classify the following galaxy. Is it spiral or is it elliptical? Now I think it's spiral because you can see the spiral arms. Sometimes if you look at it from the side, you may not see the spiral arm. And that time you have to distinguish it by looking for the disc versus an oval. Okay, so this looks pretty spiral to me. So you can say spiral, and it's going to tell you, is it correct or wrong? Okay, so I'm still in the training. This is the training part 1. Okay, so now classify the following galaxy. Let's classify this one. This is, I believe it's elliptical because you don't see any sign of spiral arms. Again, so this is correct. Okay, so now the last one. Classify the following galaxy. Is it spiral or elliptical? And sometimes you might get ones that are a little more confusing. So this does look like it has some spiral arms. So I'm going to say spiral. You could always also say not obvious if it's not clear. Now this is very little more complicated because you don't see the spiral, but you see a disc-like structure. So again, I'm going to say spiral, and that is correct. You see the disc. Okay, so last one, classify this one. It's an elliptical because you only see an oval kind of shape. Okay, no spiral arms. So we are done with lesson 1. Now I go to lesson 2. Okay, so now this is the intermediate stage. So you can all go through this and you will, your record will show that you've done this training. Okay, so lesson 2 is the intermediate. Now you have to say if a galaxy is interacting or not. Okay, so how do you say that? You have to look at these pictures and see if the spiral or the elliptical shape looks changed. So here are some of the ways you can see it looks changed. It can be pulled out, it can be stretched, which means distortion. Okay, so let's see if the example, let's practice and see if we can tell, is it interacting? Is this galaxy interacting? Question 1. I believe it is because it looks like it has a lot of small structures. So we'll say, yes, it is interacting. So tail-like features and extended features can be seen. Now, is this one interacting? Question 2. I believe it's not interacting, and that's correct because you can't really see any distortion or any features jutting out from it. Now, number 3, is this galaxy interacting? Again, it looks like it is because there are tail-like structures. Okay, so we are going to say, yes, it is interacting. Okay, so finally, is this galaxy interacting? And maybe it's not. Okay, so I'm going to say it's not interacting. It's a top view of a spiral galaxy. Okay, last one. Is this galaxy interacting? Again, it looks like it is. It's got some kind of structure that's pulled out and it looks stretched. So we are done with lesson 1 and 2. The final lesson is the advanced. And that one, you have to figure out what kind of interaction. And that's a little more difficult to do. So the type of structures you're looking for are ring structures. Then there's a shell or a fan. And to me, what I think of as a shell or a fan is it's an incomplete ring. It's just got like a fan above your head. It's part of a ring. Then there's the tidal stream or tails that you look for, or you look for a distortion, which means the spiral or the elliptical would look stretched. Okay, so let's look for some of these features. And of course, you also have to now, in this, you have to identify, is it elliptical? Is it spiral? Is it interacting? And what is the kind of interaction? All these things you have to identify. And sometimes you can't tell what it was originally. So you have a choice of stating that. Okay, let's practice. Look at this image and answer the following. Is it elliptical or spiral? I think this is spiral. Okay, so this one, they wanted to say that it's not obvious. Okay, so it's not obvious because we have a ring kind of structure. We don't really see the spiral arms. So we don't know what it was before the ring was there. Okay, so now I'm going to say, what feature did you see? We can say we saw rings. So this is the way you will get in and do it. Okay, so look at this image, and this is probably an elliptical. That's correct. And is it interacting? Yes. And what do we see? Tails. Okay, so this is the way you will do it. Finally, when you get to the end of it, you can be ready to start. Okay, so now, how do you start this? You're going to do, okay, I might, let's see if I can go to it. Sorry. Okay, so when you're ready, all you have to do is you have to complete this and go to the end and just do the start cruising. Okay, so once you start cruising, you will get to something like this. Let me make it full screen. And this is, it's a great interface. What kind of stuff does it have? It has a wheel on the right, and the wheel is what takes you to your first location. Okay, so here are some more things. There's a cluster of objects on the left. That's the settings. And the settings say you can do it full screen. You can do it in color or grayscale. So you can play with that. There's a passport feature, which tells you what are all because this Galaxy Cruise is divided into locations. And it's like a cruise. So every time you finish identifying galaxies in a certain location, it's going to stamp it saying you're done with that location. Okay, so you can take a screenshot and you get souvenirs, which says what all you have completed. Okay, so now I'm just going to do a couple of galaxies. You can do it. You can watch me as I do it. Okay, so I'm going to do full screen. So I click on my first galaxy. It zooms in like a game. It takes some time for the first galaxy to show up. So you just wait peacefully. And when it's ready, then you can. Now there is no real answer. Okay, you have to, the answer is not given. You have to do it. Okay, so I'm going to say elliptical. And I'm going to say, I'm going to say interacting. And because I see a little bit of structure, so I'm going to say tails, and then I'm going to submit it. Okay, so that was my first submission right now. Okay, I'll just do one more and then we'll finish with this for today. Sometimes it's not very obvious. It's a little tough. Okay, so again, I'm going to say elliptical, but there are a lot of spirals. I'm going to say not interacting and submit. Only if you say interacting will it ask you what type of interaction was it. Okay, so this is the way you do it. And before you, so I'm going to get out of the full screen. So there is a way after training that you can participate. Okay, so there is a way you can practice okay, I'm not finding it right now. But before you get into this, okay, yeah, in the course, there is a real classification and there's a practice classification. You can all start with the practice classification. It will give you hints and it will tell you if your solution was correct. And after that, you can start the real. And remember, there's a campaign going on and I have classified 12. I have a month to classify 1,000. Even if I classify 100 or 300, I will get I'll get a bonus in my to my credit. But students who classify 1,000, not just students, but any citizen scientist, they might get a certificate at the end of it. Okay, so with that, I went through it pretty fast, but you can take your time and you can enjoy it. Okay, so with that, I'm going to introduce you today to a very special guest. So Tejak, please come on video and hello, welcome.
Good evening, ma'am. Thank you very much, ma'am.
Okay, so today we have a very special guest because all our viewers are students from class 4 to class 9. So you will be very happy to meet our special guest today, Teja Begari. And let me introduce him. He's a class 10th student. He's a junior astronomer recognized by the Indian Book of Records. He's an ambassador at the American Association of Variable Star Observers. He has a Global Kids Achievers Award in the category of astronomy. And he has classified more than 1,000 galaxies in the citizen science project I just showed you, Galactic Cruise. So I believe he has a lot more achievements to his credit, but I'm so excited to welcome you here today, Teja. And could you tell us a little more first about which school and grade you are in?
Yeah. Good evening, everyone. This is Teja. I'm currently doing my grade 10, and I'm interested in astronomy, just like all of you are. And I'm studying in Akshara International School, and I'm currently serving as an ambassador for the American Association of Variable Star Observers. It's really very heartening to be here at this meeting and to address all of you as a fellow astro enthusiast. So I'm really very excited to talk to you forward.
So Teja, could you tell us a little bit more about your achievements and about the AAVSO and how you're an ambassador, and also some of the other projects that you are mentioned that you are involved in? And
sure,
also do talk about the awards that you have got and how you got them.
Sure, ma'am. I made a little slide, so I just want to share that. Yeah, I hope it's visible, ma'am.
Yeah, it's visible.
So
I mean, right now your screen is visible. Yes, that's right. It's visible now.
So my little journey in amateur astronomy, precisely. So yeah, I'm Teja Begari, as I introduced. I'm currently working as an ambassador for the American Association of Variable Star Observers, and I've been recognized by the India Book of Records as a junior astronomer. I basically started up with little achievements. I just would like to mention them. So I basically started with quiz competitions in the beginning. When I was a very beginner, I started with quiz competitions. And then I wrote my first international exam, that is the International Astronomy and Astrophysics competition, wherein I got the silver honor. And then I participated in the International Astronomical Union's CAP, which is Communicating Astronomy with Public 2020, which really gave me a very great opportunity to get connected with few of the internationally known astrophysicists. And I participated in the IASC asteroid search, which most of you might be familiar of. I made 3 preliminary discoveries till date and 1 provisional discovery. And then on, what I thought is this is not enough. Maybe fellow astro enthusiasts like me should also know about these kind of projects. And then I started to go to different schools in Hyderabad, and I went out of the district, and I started giving public speeches and introducing them to the citizen astronomy research. And that is when the India Book of Records recognized me as a junior astronomer. So this is one of the part of, letting people know about one of the great citizen science project. This is a really great initiative by Nila ma'am, and I'm really grateful about being a part of this. And I've also been a citizen astronomer at the National Astronomical Observatory of Japan, which you just learned about, and also Zooniverse. Uh, there's also a similar project, which is the Pune Knowledge Cluster, which is similar to the National Astronomical Observatory of Japan. But what NAOJ gives you more is there's a really great animation, and you get it like a cinema, basically. It's like really beautiful, and you enjoy while you do that. So that's something very great about this particular project. And I also did few my citizen science projects in the universe. And then I was selected as an ambassador for the American Association of Variable Star Observers. I recently got my award, that is the Global Kids Achievers Award for the category of astronomy. And I also was invited to speak at All India Radio, which is basically a central government initiative, and Tori Radio, which basically is one particular radio show which works on science, humanism, atheism, and rationalism. So I spoke about variable stars, binary stars, few different kinds of stars that Tori Radio. And then I was also invited to speak at the 110th anniversary of the American Association of Variable Star Observers, the AAVSO, where I'm currently serving as an ambassador. So that was an online talk. So I also wanted to add up my little gallery. So the top one here is my talk at the All India Radio. And this is a poster for the Global Kids Achievers Award. But I have my award right now. So this particular slide is made when I got the poster. And these are a few of my posters for a few of my talks about citizen science, astronomy, or different kinds of citizen science projects. And here's my India Book of Records for being a junior astronomer. And this is the gallery of all the different scientists from different parts of the planet. And I got a really great opportunity to interact with them. So, and after seeing my interest in astronomy, so what my father basically did is he bought me a telescope. He bought me a Celestron Astromaster 130 equatorial mount. That's a reflector. And you can see this is my telescope. And he bought me a lot of books. So these are a few of my favorite books. There are much more, but many more. But these are a few of my favorites. And I really wanted to share that with you. And it started for me at my very young age, when I was in my grade 3. So it started from my science textbook. So we had a textbook, and in that we had a 2 to 3 pages lesson on solar system. So that's the first glimpse of me seeing a solar system. So at that particular moment, I could recognize Earth. And I've asked my science teacher, what are these balls just beside Earth? So that was quite interesting for me. And then I've asked my science teacher about these planets. And she said me that these are called as planets. That was the first time when I heard the word planets. And I've started to learn about planets. And so it all started from my grade 3. Really, it's been a really great, amazing journey about working, like doing citizen science projects, because you're going to be a scientist, you're going to be you're going to contribute to real science. So you're going to analyze data, and you're going to send it to the particular organization, and then you know what they are. So that's something really great. And citizen science projects are one of the really great initiatives to get into real science and contribute to real science. And with the help of my physics teacher, Mr. Saradi, I could learn much more astronomy. And then I got in touch with a German astrophysics student, Mr. Thomas Land, and I learned much more from him. And there are many guides, other guiders to me as well, who helped me to get knowledge in astronomy. I would really like to render my very special thanks to them. This was my little slide on my amateur astronomy journey. So there's something else I would really like to share. That is the AAVSO Citizen Science Project, something really very important. So AAVSO, the American Association of Variable Star Observers, this was actually founded in 1911. So it was started from a little group of amateur astronomers. And now AAVSO has been almost every corner of the world. So you can see the red the marks there. So that's where AAVSO is now. So what AAVSO actually does is the mission of AAVSO is to enable anyone from anywhere to participate in the scientific discovery through the variable star astronomy. So it enables anyone. So if you're interested in astronomy, that is what matters. That is what something really very important. So if you're interested in astronomy and you would like to participate in different citizen science projects, so you're really very welcome to join AAVSO and other citizen science projects. And we have researchers, we have observers, we have educators, and a really very dedicated team of volunteers. We basically do our research on we not only observe variable stars, but we observe sunspots, we do exoplanet database, and there are really very great observers. Very soon I'm going to start my observation of variable stars. I'm really very excited to be a part of that. And we have educators and also volunteers. So variable stars are those kind of stars whose brightness basically changes as seen from time intervals on Earth. So you can see a few stars here are actually changing their brightness. So that's a day-to-day basis of observation. So those kinds of stars are variable stars. And we have light curves. So there's a photometry. There are softwares which help you to build the light curves. And there's a so you can see we have eclipsing binaries. We observe them, sunspots. We observe the sunspots as well. We basically make the light curves and we send it to the AAVSO. So there are a lot of resources for us in the AAVSO. So different stars of interest. And if you would like to observe few stars, you can select them, and you have tools to observe them. You can make some variable star chats, and you can send them to the AAVSO. And as I mentioned, that you have different softwares. So VFOT is one of them. You can make light curve and send it to the AAVSO, and a lot of educational material. And we also have a publication, which is the JAAVSO, the Journal of the American Association of Variable Star Observers. So we basically, this is basically for young astronomers. They can learn much more from this journal. The recent news in astronomy will be published. And we recently got the exoplanet database as well. And we also have spectroscopic database. So you can see a few of the recently published spectroscopic database. And we have observing sections. We can learn much more about the variable stars. And you can ask your questions in the discussion forums. And you, of course, have free online events. With this, I would really like to stop my presentation. And yeah, so that was a small presentation on astronomy and variable star astronomy, which what I basically did.
So that's great. Congratulations, Teja, on your recent award. And it's been really great hearing from you. The students are so inspired on the YouTube channel. They're all saying, it's very inspiring listening to you. And some of them are asking, yes, how do they get into some of these citizen science projects? So you've already mentioned AAVSO, which is the American Association of Variable Stars Observatory. And you are participating right now in the solar observation part of it, but there is a variable stars also. So there are two parts to it. And of course, as I mentioned, Galaxy Cruise is the other option. Kids from class 4th can also do it, and class 4th onwards. And of course, both Teja and I are, we do a lot of projects in Zooniverse. So hopefully I'll do another webinar to introduce you all to Zooniverse. So thanks, Teja, for being with us here today. And Arjun, are there any questions for Teja in particular, do you think? Or
and no
or should we
questions,
move ahead?
not, but comments saying that they are really inspired by Teja. Yes. Yeah.
there's a lot
So
of,
you can move
yeah.
ahead, ma'am.
Yeah. So thank you, Teja, for being here today. I don't want to hold you back because I know you're busy in class 10. So thank you again. And now, so I will share, I'll share your name with students, so maybe they can go and see your Facebook or the AAVSO link. Arjun will put those in Galaxy Cruise. We'll put them in the YouTube description. So thank you again, Teja. So,
yeah, thank you for joining.
Thank you very much,
thank you for joining.
Really great. Yeah. Thank you very much, ma'am, for this wonderful opportunity.
Okay, great. It's been great having you.
All right. So yeah, so hello students. So like I told you, this was all about our today's session. So I hope you really like the Galactic Cruise citizen science project. As you all, as I've told you in the chat as well, that the link for the citizen science project is given in the YouTube description. So if you can't see that, try reloading your YouTube and you will be able to see that. Yeah. So that was about the project. Now, I would like to ask you all to, if you let's say if you have any questions regarding the NAC exam or the onboarding or any such thing, please let me know. I'll be taking a few minutes to answer your questions and then we will end today's session.
Arjun, before we do that, I'll just maybe talk to them about some of them about what NAC is, because some of them may not be there yet. Okay, so I'll just share that and then you can tell them about their doubts.
Sure.
Okay. So that's okay, so I believe a lot of you who are here with us on YouTube today are already registered in National Astronomy Challenge. But if you haven't registered yet, then you only have a week more to do it. So National Astronomy Challenge is a challenge like an Olympiad to test your knowledge of space and astronomy. Okay, so it's focused on astronomy and space. It's you get access to world-class content. What does that mean? It means we give you curated content as soon as you register, which you can study, and that's going to help you with this challenge or exam. And additionally, students who are registered get exclusive engagements, and that means webinars like we are doing today, and we've been doing it. And next week we have several webinars. So we also have a couple of STEM workshops right now, and there are quizzes, and we tell you about celestial events. So with the last few weeks to go, we do have a webinar tomorrow on JWST, the successor to Hubble. And we have 3 more webinars on Monday, Tuesday, and Wednesday coming up. So these are exclusive to NAC registered students. So you'll get a lot of information with us. So once you participate, everybody will get a participation certificate and your grades or percentile. The national winners will get a lifetime opportunity, once in a lifetime opportunity to visit ISRO with us. So if you haven't registered yet, there's only 1 week left for registration, and that's go to this website and you will find contact information there. So with that, I'll let Arjun sir talk more about whoever is in NAC, they can, if they have any questions.
Yes, thank you so much, Lam. So I have been getting a few questions from the student. So the first question I would like to, let's say, address is the dates for the NAC exam. So many of you have been asking me, sir, what are the dates for this grade and that grade? So to all of you, I would like to tell that students, the dates for the NAC exam is mentioned on the NAC website. That is nationalastronomy.org. Right. In any case, I would like to tell you the dates here also. So the exam, so the Olympiad for grade 8 and 9 will happen on 8th of January 2022. For grades 6 and 7, it will be on 15th of January 2022. And for grades 4th and 5th, it will happen on 22nd of January 2022. Yeah. So I hope that clears it. But in any way, case, if you want to see when the exam will happen, please visit our website. Okay. Any other questions, anyone? So yeah. So, okay. So coding expert. So someone asked, sir, I don't have any ID for onboarding. How to get the ID? So you must be having any ID, right? Any identification card that you must have in which your name and your grade is mentioned. So if you don't have any such ID, please write to us at hello@nationalastronomy.com, the support link that we have provided in the description, right? So, and we will be helping you with whatever, let's say, the solution we can give in. Yeah. So if you, yes. So someone says, sir, if you don't have any doubts, you can leave. Yes, Viraj, you can leave. And is AAVS is free to use? Yes, it is. Yes, Bhakti, it is free to use. You won't have to pay anything for it. Yeah. So yes, someone are asking me about the mock test. So students, please wait. Your mock test will be visible to you in the next day or two. Yeah, you will be able to see it on your learning platform, but please ensure that, please note that the mock test that you are getting, it will only be telling you the exact format in which the question will appear. All right. So how the question will appear, how you will have to answer them. And basically it doesn't have any provision to go back, right? So make you what we say, in the frame of mind that how exactly the format of the exam would be. It is for that. Okay, so the question obviously which you get in the sample paper or the mock test will not be appearing in your final exam. So don't you worry about it. Okay, so don't expect that here.
So Arjun, questions on how long is the duration, how many questions, and also is it tough?
Obviously, the Olympiad will be tough. Yes, so I won't say.
However, I will say that if you read the content, it's going to be a lot of help. Yeah,
exactly. I don't want you to shy away from reading the content just by saying that your Olympiad will be easy. Yeah, read it thoroughly and maybe you'll be able to crack all the questions. Yeah, but the passport, okay, Harnish, someone is asking, his passport is okay to use as an ID? Yes, Harinishri, right? So it is okay to use as so what we need actually is your photograph and your name to be visible very clearly so that we can map you from it, right? So that we can verify that, yes, it is the same student. All right. And we'll be using that ID for our later verification as well. Yeah. So any ID is free to use, including your passport.
So what is the duration and how many questions?
Duration for the mock exam, there won't be any duration. Yeah.
No, for the real exam.
For the real exam, yes. Yeah. Right. So don't worry about the exam, students. So just before the exam, I will be uploading a video, a separate video explaining the do's and the don'ts and all the things that you'll need to ensure during the exam. So don't worry about that for now. Just focus on going through the material and reading about all we have. We want you to read for the Olympiad and be open, basically be available to all the communication that we send. Right? We
keep on sending you what time is it? They're asking.
So the time, exactly. So student, these are the kind of questions now I want to address in that video. So basically for this Olympiad, what we are going to do is we are going to give you a window, a time window in which you can log in at any particular time, which is what we say suitable to you. So again, how you have to set all the basically what you need to take care of, what is the do's, what are the don'ts, I'll be telling you in a separate video. Just and we will be sharing those video with you on your learning platform as well as on your WhatsApp. So keep an eye for that. Okay, when is the mock exam? So Likhita, again, I would like to clarify that there is no mock exam as such. What we are going to do is we are going to give you a sample paper or a mock test paper, which will tell you the exact format in which the question will appear and how will it be basically. And okay, so in the format in which the question will appear and how you have to approach it. Okay, that's all. Yeah, so no time limitation, no, basically you won't be getting any question from the mock in the real exam also, that we have also ensured. Okay, what is the last date for onboarding?
Yeah, and some of them have questions about, again, the content, but that once they register, they should be finding that, right?
Yes. So exoplanet, I'll just very briefly tell you, like exoplanet is basically a planet which is revolving around any other star, but not the sun. Okay, all those planets, we call them exoplanets. All right, so another one, can you please suggest? Last date, yes, someone is asking last date for onboarding. So for now, we have kept the last date for onboarding to be 25th of December. So please make sure that you complete your onboarding before that date. If you face any problem, please don't delay writing the mail to us on our email ID hello@nasaastronomy.org. That email ID is also given in the YouTube description if you see it down there. Yeah. All right. So that was the questions, and thank you so much.
Somebody asked, what is the last date for onboarding?
Yeah,
I have
already
NAC
told you.
exam after installing Proctor track and completing the onboarding.
Once you have completed the onboarding, don't worry about how you have to give the exam. You don't have to do anything extra for your exam. Okay. But yes, there are some certain things you need to take care of. And like I have been telling you multiple times, I will be uploading a separate video to explain these things to you. Yeah. Can my name?
So some students are asking, can it be out of syllabus? So I'll just answer that. If you read the content, you'll get the overall knowledge, and most of the questions will come from related topics. It might be a little bit more because it is an Olympiad, but it will be related, and there will be some current affairs kind of questions.
Yes. Yeah. So I would urge you to keep in touch with all the latest happenings in the world of astronomy. And so that was so near my name in the profile section is coming. All right. So student, if in your LMS, some other name is coming apart from your name in the profile section, you can always click on the profile and change the name from there. Okay. And please ensure that the name mentioned in the LMS is your name and no other name. Okay. So
yes, the exams will be online, as somebody asked.
Yes.
And,
yes, it will be online.
If you've registered to NAC Olympiad, then already you should be able to log in and receive the study material, right, Arjun? That's what somebody's asking. So
yes, if you have registered, you should receive the link for the for accessing the study material and for doing all these onboarding and all these things. Basically, within 48 hours of registration. If you haven't received it yet, please write to us and we will ensure that you will receive it at the earliest. All right, scanning and face. Yes, that is on. Someone is saying, can I use Aadhaar card for onboarding? Yes, you can. Right, sir. Those other like galaxies like Andromeda have life in it. We don't know.
Arjun, let's do the NAC. Don't mix up because that will mix it up too much.
Yes, exactly. I am not mixing it up. I have my school exam on 8th Jan. So if the time is same, can we give them? Yes. So okay. So Nilarka Pahari has some very genuine and valid question that some of you might be having your exams on the date of the Olympiad, right? So like for the Nilarka, the exam is on 8th only. So like I told you, basically what we will be doing is we won't be having the Olympiad at the exact same time. We are going to give you a window, let's say from 9:30 or 10 in the morning to 5 in the evening. And any 1 hour in between, you have to keep for your Olympiad, and you can log in and start doing your exam at any given time within that window. Okay. So, but please ensure that you do that. And if you're unable to do even that, then please write to us and we will see if how we can help you with that. Okay.
So, did you not answer Yashash's question? I think you did. How to get the NAC exam after installing Proctor Track and completing onboarding? He's repeatedly asking.
So here, Yashash, like I have been telling you repeatedly, I'll be uploading another video, right, to explain you that once you have completed the onboarding, how you should go ahead with your further processes. So for now, please focus only on reading the material. All right. And keep checking your email and your WhatsApp for the communication that we keep on sending you. All your questions will be answered timely. All right. Yes. So with that, I think, ma'am, we have answered most of the questions. So I would like to end the session here. So all the best, students. We will be meeting again tomorrow for our another interesting session. And basically, you will be getting the link for that on your WhatsApp.
And that session is on James Webb Space Telescope, which is going to be the successor to Hubble. And it's going to be launching later in December. So it's going to be very exciting. So do join us at the same time.
All right. Yeah. Okay. So all the best, students. And